Alright, welcome back to Discrete Mathematics and its applications with me, Adila Krishnadi, and we shall continue with answering these exercises. So you have two questions here. The first one is to find the composition of R and R. So you could compose a relation to itself as long as it's well defined. So compose R and R, where R is the set of pairs A comma B such that A is a parent of B. So, well, let's say that R is defined on a set of people. And then the second question is you have R1 to be a set of pairs A comma B real numbers such that A is greater than B, and R2 is set of pairs of real numbers such that A is greater than or equal to B. And the question is, what is the composition of R1 and R2 and the composition of R2 and R2 itself? So let's start with the first one. In the first one, we have a set of R, A comma B, set A is a parent of B, and what is the composition of R and R? So to get an idea what will be the answer, let's draw some examples. So let's say you have Rudy is a parent of say Ilham, right? Now and then Ilham is and what would be, say Ilham is a parent of, say so suppose he has a son called Yusuf. Now if Ilham is a parent of Yusuf, then Ilham is related to Yusuf by R, right? So what will be the, or let me just write it down. So this is parent of, right? Is parent of. So what would be the relation between Rudy and Yusuf? Well, you could guess that it's actually is parent of, right? Yeah, so therefore the relation of the composition of R and R is the set of pairs of A comma B such that A is a grandparent of B. Yeah, so that's the first answer, the answer of the first question. So how about the second question? So in the second question, you are given R1 and R2 there, and we want to find out the composition of R1 and R2, and then composition of R2 and R2. So let's start with the first one. Both relations relate pairs of real numbers. So to get to the answer, it might be instructive to simply draw a few examples. So let's start with a concrete example. Say the number 4. The 4 is related to, say, 3 by R1, right? And then what would be the real number to which 3 connects by R2? Well, 3 could go from 3 using R2, you could go from 3 to, say, 1, right? Or, well, 3 itself, or maybe, well, 2.5. and you have many of them, right? So what is the relation between 4 and 1? Yeah. Or 4 and 2 comma 5, or 4 2 and 3, right? So that will be the composition of R2, R1 and R2. So what exactly is R1 and R2? Well, you could do it this way. So say composition of R1 and R2 is a set of pairs of real numbers a comma c, such that there is a b, a real number, with a comma b in R1 and a b comma c in R2, right? And this is the same as, of course, set of pairs a comma c, such pairs of real numbers, such that there is a b, a real number, with a greater than, sorry, a greater than b and b greater than or equal to c. Now if you know that a is greater than b and b is greater than or equal to c, then obviously uh so c could be the same as b or could be less than b, and then b must be less than a. So therefore what is the relation between a and c? Then obviously uh, uh, between a and c, you know that actually a is greater than c. Yeah. Now that is the composition of R1 and R2. How about composition of R2 and R2 itself? So now, right, you don't have to draw this time, but you follow the same line of reasoning. Take a comma c, pairs of real numbers, such that there is a b, a real number b, with a comma b in R2 and b comma c also in R2. Sorry. So this is the same as a comma c pair of real numbers, such that there is a real number b with a greater than or equal to b and b greater than or equal to c. So if you have these two, then obviously a comma c, the composition of R2 with itself is set of pairs of real numbers a comma c, such that a is greater than or equal to c, which is actually the same as R2. Okay. So that's the answer for the second question of this exercise, and let me stop here, and we'll continue on the next video, the powers of binary relation.